Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. Here's some information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smartyurl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smartyurl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. You are given that the joint density of random variables x and y is f sub xy of xy equals to x plus y for x between 0 and 1 and y between 0 and 1 and 0 otherwise. What is the coefficient of variation of z equal to x plus y? And here's the solution. So we use the formulas for the mean. E of z is e of x plus y, so it's e of x plus e of y, and variance. Variance of z is variance of x plus y, which is variance of x plus variance of y, plus two covariances of xy, and calculate directly. We have f sub x of x equal to the integral from 0 to 1 of x plus y dy, so over all possible values of y, and it's the joint density that we integrate. And that's x plus 1/2 y squared evaluated from 0 to 1, so it's x plus 1/2. For x between 0 and 1, 0 otherwise, of course. And because of symmetry, f sub y of y is y plus 1/2 for y between 0 and 1 and 0 otherwise. Therefore, e of x is the integral from 0 to 1 of x times x plus 1/2 dx. And that's 1/3 x cubed plus 1/4 x squared evaluated from 0 to 1. So it's 4/12 plus 3/12, and that's 7/12. And e of y is also 7/12, so that e of z is e of x plus e of y. That's 14/12, which is 7/6. E of x squared is the integral from 0 to 1 of x squared times x plus 1/2 dx. That's 1/4 x to the 4th plus 1/6 x cubed evaluated from 0 to 1. So it's 3/12 plus 2/12, so it's 5/12. And the e of y squared is also 5/12. So that the variance of x is e of x squared minus e of x, the whole quantity squared. That's 5/12 minus 7/12 squared, so 60 over 144 minus 49 over 144, if we find the common denominator, and that's 11 over 144. And of course, variance of y is the same, 11 over 144, because of symmetry. Also, e of xy is the integral from 0 to 1 of the integral from 0 to 1 of xy times x plus y dx dy. That's the integral from 0 to 1 of 1/3 x cubed y plus 1/2 x squared y squared evaluated from x equal to 0 to x equal to 1 dy, and that's the integral from 0 to 1 of 1/3 y plus 1/2 y squared dy, which is 1/6 y squared plus 1/6 y cubed evaluated from 0 to 1. That's 1/6 plus 1/6, and that's 1/3. And covariance of xy, therefore, is e of xy minus e of x times e of y, so 1/3 minus 7/12 minus 7/12. That's 48 over 144 minus 49 over 144, and that's negative 1 over 144. And the variance of z is the variance of x plus y, which is the variance of x plus variance of y, plus two covariances of xy. So 11 over 144 plus 11 over 144 minus 2 over 144, and that's 5 over 36. And therefore the coefficient of variation of z is the standard deviation of z, which is the square root of 5 over 36 divided by e of z, which is 7 over 6. And that's the same as square root of 5 over 7, which is approximately 0.31943828, and that's answer E. Please remember, this is copyrighted material. The problem itself was created by me, and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.